Okay, welcome to Lime Time in Texas, our podcast series. And I'm Dale Rand with the Lime Association of Texas. I'm the executive director. And today I'm covering the topic of soil stabilization and understanding how that starts with understanding grain size. So you need to know what the soil grain size is before you know if you need to stabilize the soil and what type of soil stabilizer you're going to use. So just a quick recap of some things we've talked about in a previous podcast, or part one of this, was that soils are typically defined into two groups, both coarse grain soils and fine grain soils. Coarse grain are typically made up of sand and gravel and anything larger than that. Fine grain soils are typically referred to as the silts and the clays, anything finer than that. So if you look at the picture of, it basically goes through every type of soil size, going from boulders, cobbles, gravel, and up to silts and sand, silts, and clays as you go from the bottom to the top of that slide there. And again, they're all defined by their size. So that's what defines every type of soil that we have. So I want to spend a little bit of time talking about the soil pyramid and how this really defines what the characteristics of the soil are. So on this particular slide, we see clay at the top, silt on the bottom right-hand side, and sand on the bottom left-hand side. In real life, you very rarely see pure clay, pure silt, or pure sand. You usually see a combination of all of those. And anytime you have a combination of those, it's typically called loam. So the definition of loam just means it's a combination of either sand, silt, or clay. So going through some of these characteristics on this soil pyramid, I'm going to particularly focus only on this time on strength, cohesion, plasticity index, the size, the drainage, and the additives that you would need. So the main two soil types that we see in Texas are either clay or sandy soils. As you go out in West Texas, you see a lot of sandy soils. In Central to East Texas, you see a lot, and North and South Texas, along the I-35 corridor and east, you see a lot of clay soils. So basically, the more clay that you have in there, it's going to have poor strength, it's going to have great cohesion, it's going to have really high PI. It's typically always going to, clay has tiny particle size. It doesn't drain very well. It holds water. Now, which is great if you're growing crops or something like that, but when you're building a highway, that's not a good characteristic to have, because that makes it expansive when it's wet and shrink back when it's dry. But you know, if I'm a farmer, I'm going to look for something right in the middle of this pyramid and get something that's got a little bit of sand, a little bit of clay, or something loam to where you've got some water in there. But now, as you go down to the bottom left, as you move closer to pure sand, the strength actually goes up. You get pretty good strength characteristics. And as you move into the larger size, which is gravel, if you move off this pyramid and talk about the sizes that would be below or larger than sand. So sand has good strength. It has very poor cohesion typically. It's not going to stick together very well. It has very low plasticity index. It has a relatively large particle size compared to both silt and clay. And the additive, because of its particle size, it also has very good drainage characteristics. So you can take a dry sand, pour a cup of water in it, it's going to drain that water off pretty quick and dry itself back out. So now if you're going to stabilize a sandy soil, so the additive that you would typically need there is something like a Portland cement is going to be the most common that you would use. If you move up to the top of that pyramid, we've discussed this before in some other podcasts, is when you've got clay, you're going to need to use lime. It uniquely works with the very fine particles that have silica, amorphous silica, and aluminum in them. So this is basically what I just call the soil pyramid. And so having a good understanding of this really tells you a lot about which type of soil that you're going to need to use for any given project, which type of stabilizer that you're going to need. Now, I'll just briefly mention silt on the bottom right-hand side. As you approach 100% silt over there, you're definitely going to need to remove and replace that material, bring in some good select fill. I will caution you on silt. It's not that uncommon to see silt mixed in with some clay sometimes, and it can kind of fool you a lot of times into thinking you've got a low PI material. And we've seen some big problems on some construction projects recently in Texas to where a silty clay basically had a low PI, and they brought it in as a select fill. It ended up having very poor strength characteristics. It was failing during the process of construction. They had to remove and replace it. So generally speaking, I'd say if you run across silt and you know you've got a highly silty material, just don't use it. It's gonna cause you problems. So overall, talking about this, what I'm just calling the soil pyramid here, it's good to understand what you have out on the project so that you know, one, do I need a stabilizer or not? So if you've got a lot of clay, the higher percentage of clay, you're definitely going to need to use a stabilizer, or remove and replace that material would be your options. If you've got a sandy soil, you may want to stabilize it, or you may, and if you're going to stabilize that, you'll typically do it with the Portland cement. But a lot of times, if you have a coarse enough material, you may not use a stabilizer at all. And then if you get into silt, you need to just avoid using it at all costs if you can. So I'm going to just briefly, I've kind of covered this slide before in some of our past podcasts. I just wanted to illustrate here, because we showed the sizes and all of that, but I want to illustrate one more time how fine the clay is and how different it is than everything else. So clay, if you look, you could not see it. You can't see it with the human eye here. It's so small that right next to the silt there, you can see that a silt particle, you could see it because it's going to be, that's about the largest you would see silt. But sand particles, now let me just point out that the scale on this is only 1/4 of an inch wide, so it's 6 millimeters. So what you're looking at is on the far left a sewing needle, and then a sand particle right there in the middle. And so, but if and the clay is on the far right. So clay gets to 1 micron and less typically, and can get much, much finer than that. So to see clay, you're not going to see it with the human eye. If you magnify it 2,000 times, this is what it looks like. And I've shown this a number of times in some past presentations, but this kind of gives you an idea. This bottom one is a montmorillonite clay. It had to be magnified 20,000 times to be able to see that. But what I want to point out is that what is unique about clay is because the particles are so tiny, and it's all made of silica and alumina, it's actually what we call amorphous silica. It means it's capable of changing. So that's why lime works to stabilize that. We can turn it in pozzolanic cement because that calcium can get in there and stabilize that material. This is TxDOT's guideline, and again, these are some things we've covered in some previous podcasts, but just a review that as you go from gravel to clay, you're typically going to, the stabilizer of choice is typically going to be something like Portland cement as you're into the coarse grained soils on that far left that are low PI. As you move to the fine grained sizes, the clay on the far right, typically lime when you get above a 15 PI, and particularly when you're in the 40, 50, 60 range, PI is typically going to be exclusively lime is the only thing that's going to be very effective in stabilizing those materials. So just some of this, summarize the stabilization considerations for coarse grained soils. For one, stabilization is not always necessary. If it's a sandy gravel or something like that, you may be able, and particularly if it has a little bit of clay to kind of stick it all together, you may not need to stabilize it at all. But if you are going to stabilize it, the best stabilization option includes Portland cement is the most common. If you're into gravel, you can use asphalt. And there are sometimes in the past we've used, and there are still used today in some locations where they use the lime fly ash blends, where it's more of a sandy clay or a clay sand. So those are your combinations there. When you get into the fine grained soils, the stabilization considerations are, well, for silt, you want to replace it with select fill. That's the preferred option. You really don't have another good, there's not a good stabilizer that's going to be able to treat silty soils. For lime, for clay, the lime stabilization is typically always going to be the stabilizer of choice. The only other choice really is to bring in a select fill. You can go through and do the cost analysis and see what it costs to remove and replace that poor soil, or whether it's cheaper or more cost effective to stabilize it in place, which the vast majority of the time it's way cheaper to put lime stabilizers in place because you can add 6% lime in there, typically in that range, and stabilize the soil versus taking out 100% of the soil and trucking in 100% new soil that may or may not have some problems itself. So stabilizer of choice is lime. I say here that the worst option is ignoring it. So we have seen combinations, or not combinations, we've seen in the past where people said, well, I'm just not going to do anything. I've got a clay soil, but I'm going to just build on top of it. And most of the time you're going to regret that. Over time, it's going to, eventually that soil is going to, particularly if it's a pavement that's got any kind of, traffic on or anything, it will typically fail over time as it shrinks and swells and moves around. And I say here the second worst choice is trying to bridge over it with an additional base, asphalt or concrete. We see this sometimes that people, I've seen it, for example, on concrete pavement, they say we're going to add an additional inch of concrete and just bridge over this clay soil. And generally speaking, that's not a good choice. Lime, and clay soils, I've mentioned this before, have expansion pressures up to 30,000 psi. It's going to break out, push out anything that's on top of it. So 12 inches of concrete is not going to keep a clay soil from moving underneath it, or under the wrong conditions where it gets water into it and water can come in and out of it and it can shrink and swell. So main advice here is if you have a clay soil, you really need to deal with it one way or the other. And most of the time that your best option is going to be lime stabilization in most cases. So we appreciate you joining us today. Hopefully you learned something new about soil stabilization and how the grain size affects your choices when it comes to stabilizing soils. Thank you. Thank you for watching this episode of our podcast. If you want to learn more about the use of lime, reach out to us on our website at limetexas.org. You can also email me at dalerand@limetexas.org. And please follow us on LinkedIn and subscribe to our YouTube channel. Thank you for watching.